torsion, a moment that is applied about the longitudinal axis. In case of bending, we apply the moment about the transverse axis, about this horizontal axis, which is, we can say, y. So this is if it is x, and this is y and z. So this is in case of bending, the moment is applied about this y or z axis, perpendicular to the longitudinal axis. But in case of torsion, we apply the moment about the longitudinal axis, about this axis x of the member, and this moment is termed as torque, and this moment tend to twist the member. So it will twist like this about the axis, about the longitudinal axis, and this phenomena is termed as torsion. So twisting about the longitudinal axis is termed as torsion. Okay, to resist the torsion, which type of section are good and which type of section are not good? So for a circular shaft or closed circular section, the plain circular section remain plain, and the cross section at the end of the member remain flat. So here we can see the circular section remain plain and the end section is again plane, and the length and the radius of the member will not change. So if the member is circular shaft or closed circular section, just applying the torque, by applying the torque there will be no change in its length as well as radius. So plain circular section remain perpendicular to the longitudinal axis. So these assumptions, just like in case of bending, the plane section remain plane and perpendicular to the neutral axis. The similar assumptions or similar phenomena occur in case of circular shaft as well as closed circular sections. There is no distortion in the section. But in case of non-circular section or open section, so when we apply the torsion, there will exist wrapping. The cross section will turn into zigzag shape, into distorted shapes, which is termed as the radius and the length of the member will change. So there will be unequal deformation in the fibers of the member. The question is, why this happen? Why in case of open section there is distortion in the member or the twist in the member? So this is because the phenomena of shear flow. So torsional stiffness of open section is significantly less than that of closed section due to reversal of shear flow in case of open section. So here the shear flow will be like this, and then in this direction, in this direction, and at the end again it will turn back. So at any section, if we cut a section over here the stresses in the wall will be like this, just like the flexural stresses. On one side there will be compression, and on the other side there will be tension, and at the center there will be some material where the stresses is zero. So as a result, the full thickness of the member will not be utilized, the full material strength will not be utilized to resist the shear forces or the shear or the torsion. As a result, because of this distribution of stresses, the member will buckle locally, as well as there will be distortion in the section, and the full strength of the material will not be utilized. As a result, just at a small torque, the member can be twisted or member can be sheared. But in case of closed section, the shear flow will be like this. It will be in one direction, and at any section, if we cut a section at any point, so the distribution will be like this. The full strength of the member will be utilized to resist the torsion. So that's why if we design a member for torsion, in that case the best selection will be a circular shaft, solid section, circular hollow section. Closed section is also a good option. If it is not a circular, then it should be a solid section or closed section. But C section, angle sections, these are not the good option for a member which is subjected to torsion. We need to avoid this type of section for torsional members. So here we have a model demonstration that if we take two rods, two sections, hollow section, in the first case it is open section, and in the second case it is a closed section, and we apply a torque on that section. So the first section will twist easily just with the help of hand, but in case of second section, where the section is a closed section, so it will not be easy to twist such a section. So this is because in case of closed section, the torsional stiffness is significantly high. Okay, if we are supposed to use some open section like C section, then it is necessary to apply the load at the shear center. If the applied load is passing through the shear center of the member, then there will be no torsion, and if it is acting away from the shear center, then there will occur torsion in that member. So for that we have a model demonstration. We have 3 beams, cantilever beams made up of channel section, and in the first case the load is acting away from the shear center, so because of that load there is bending as well as twisting in the member. In the second case, the load is passing through the shear center of this section, so here only we will have bending in downward direction, there will be no torsion. And in third case, if the again load is acting away from the shear center, so there will be bending as well as torsion in that member. So if we want to avoid the torsion in the section, so we need to apply the load at the shear centers. So that is why when we are going to design the purlin in case of truss roof system, we use Z section, because here the load will pass from the shear center of this section. But if we use C section, in this case the load will pass from here, so it is away from the shear center, so in that case there will be twisting in the member. So here we have a practical application of this concept. To avoid the torsion in case of bridge decks, box girder, we use box girders, because in case of bridges the load of vehicle can act on any side of the deck slab. For example, load is acting over here, and if we have a beam or the girder at the center, so because of that load there will be a torsion or twisting inside this girder. So to resist that torsion, we provide these hollow sections, box girder. So this is a closed section, so this can resist the torsion very effectively.